Okay, a very good morning children. Today let us discuss Euclid's division lemma. Okay, Euclid, what is Euclid? Euclid actually, who is Euclid? He was a great mathematician of Greek. He was a great Greek mathematician. Okay, so he had given a lemma. Now look at the word lemma. What does lemma mean? Lemma means what? It is a proven statement. Proven statement? What is proven statement? Proven statement means it is already proved. It needs no proof, and we will use this statement or lemma to prove other statements of mathematics, particularly in geometry. Okay, so what is Euclid's division lemma? To understand, let me give you a simple example. Suppose you are given two numbers 58 and 9. You are asked to divide 58 by 9. So you can easily do division. The quotient is 6 and the remainder will be 4. You see. So on dividing 58 by 9, we got quotient 6 and remainder 4. Now tell me children, will you get any other quotient and remainder, that is any other quotient other than 6 on dividing 58 by 9? The answer is clearly no. On dividing 58 by 9, the quotient will only be 6 and the remainder will only be 4. It cannot be any other number other than 4. That means what I want to say, here the quotient and remainder are unique. Unique. What is unique means? What does unique means? Unique means your one and only one. That means on dividing 58 by 9, we cannot get any other quotient other than 6. Similarly, we cannot get any other remainder other than 4. Okay. So here the quotient and remainders are unique. Now the point is, how to confirm or how to check, how to verify that this long division process is correct or not. This thing you have been doing since junior classes. Okay. So what is the process? You multiply the divisor and quotient, that is 9 by 6, then add the remainder. If you got the dividend, then your division is correct, otherwise your division is wrong. Okay. So now let us see how to verify or check. What will I write? 58 equal to 9 into 6 plus 4. Clearly 9 into 6 is 54, 50 plus 4 is 58, hence my division is correct. Okay. So this verification of long division, checking or verifying long division process is nothing but your Euclid's division lemma. Here it is for only numbers. We will now discuss this one for integers. Okay, you see here 58 and 9. These are two integers, positive integers. You know what are integers? 0 is an integer. There are positive integers like 1, 2, 3, 4, etc. Minus 1, minus 2, minus 3, etc. These are negative integers. So here 58 and 9 are positive integers. Now we are discussing Euclid division lemma only for positive integers, but it can be extended to negative integers also. However, the Euclid division lemma for negative integers, it is beyond the syllabus of what? CBSE. Okay. So we will discuss only Euclid division lemma for positive integers. Okay. Now instead of taking 58 and 9, let us now state Euclid division lemma. As I told you, Euclid division lemma is nothing but it is the repetition, or you can say it is the alternative form of verifying long division process for positive integers. So let us state and understand what is Euclid division lemma mathematically in detail. Okay. So you see, instead of taking 58 and 9, what Euclid did, he took two integers, say a and b. You see, he took two integers, say a and b. Okay. Now what he said? He said on dividing a by b, here a and b are non-negative or positive integers. He said on dividing a by b, if the quotient is q and the remainder is r, suppose the quotient is q, it is again a non-negative or positive integer. The remainder r, it is also a non-negative or positive integer. So what Euclid said? He said on dividing a by b, which are non-negative integers, if the the quotient and remainder are q and r, which are again non-negative and they are unique. Unique means they are only one and only one. The quotient and remainder, which are also non-negative or positive integers, are unique integers. So on dividing a by b, if the quotient is q and remainder is r, then he said, therefore he said a will be equal to b into q plus r. You see, as per this formula, verifying your long division process, a equal to bq plus r. Okay. And what is the condition? What condition this relation must satisfy? This relation must satisfy the condition where r is less than b and greater than equal to 0. Means what? What is the meaning you see? The remainder r must be less than b. B means the divisor, and it should be greater than or equal to. That means on dividing a by b, if the quotient is q and remainder is r, this r must satisfy that relation. This r must satisfy this relation. It should be less than the divisor and greater than or equal to 0. Okay. So this is what known as your Euclid's division lemma. Okay. Now we can easily state what is Euclid's division lemma. Euclid's division lemma says, what does it say? It says if a and b are two non-negative integers, then on dividing a by b, if quotient are q and r, okay, which are again non-negative integers or positive unique integers, then a is equal to bq plus r, where r less than b and greater than equal to 0. Okay. Now we will discuss it in a broad manner. Let us see. Now what will happen? Suppose this remainder is 0. You see, look at the condition here. The condition is r is less than b and greater than equal to 0. Okay. Suppose the remainder equal to 0. What will happen? If remainder equal to 0, then put r0 here. Then a equal to bq plus 0. Okay. So which is equal to bq. Now see. bq plus 0 means bq. So a equal to bq. What does it mean? You tell me. Now a equal to bq means, you see, a is what? Divisible by b. Okay. A is divisible by b. Now if a is divisible by b, what does it mean again? It means b divides a. You see, this is the symbol for divides. I am putting it in bracket. Look at. B divides a. You see, a is divisible by b, or b divides a. That is, b divides a. Okay. You see. So, if remainder is 0, as I told you the condition, this condition must be satisfied. In order that Euclid's division lemma will hold good or true. So, this condition must be satisfied. Now, if r equal to 0, what will happen? A will be bq equal to bq. That means a will be divisible by b. And if a is divisible by means b divides a. Okay, b divides a. Now, suppose the remainder is not 0. You see, I am writing here. Suppose remainder not equal to 0. What will happen then? What will happen? Suppose the remainder is not equal to 0. If remainder is not equal to 0, then definitely the remainder will be either less than b or greater than 0. Very clear. Okay. If remainder is less than b and greater than or equal to, there are two conditions, greater than and equal to. So when remainder equal to 0, then a will be equal to bq, means b will divide a, or a is divisible by b. And if r is not equal to 0, if the remainder is not equal to 0, then the remainder will be what? Definitely less than b and greater than 0. B means the divisor. So the remainder will be less than the divisor and greater than 0. Okay. So this is what your Euclid's division lemma is. Okay. This Euclid's division lemma finds a wide application in the field of mathematics. I think children, you understood what is Euclid division lemma. Okay, we will discuss its application in the next class. We will see how Euclid's division lemma is applied to problems in the next class. I hope all of you understood. Okay, so we will meet again in the next class. Thank you.